Hello. So hello and good afternoon everyone. We'll start today's tutorial. So tutorial for week 4 engineering mathematics 2. Okay. So hello. Today we will be doing few examples from assignment and one or two extra questions. Okay, on the like poles and residue theorem, Cauchy integral formula. On mainly on this we will be solving few questions. Okay, so So few things we have to remember when a function, we have a function from in a complex valued function. So we define something called residue. So before that, so residue will be uh, for a pole. Okay. So that first of all, if you have a pole, we can define what is called residue, and that will be by this, where C is a pole. I mean, for a simple pole, here it is written for a simple pole, that pole is C, right? So then you have residue of F is limit of Z tends to C, Z minus C times Fz. So what will be a simple example? So if you take Fz to be 1 by Z minus C, you can see C is a singularity point here. So what you will have at the limit Z tends to C, Z minus C times Fz will be 1. So a residue of the pole C here is 1. Why we are doing this thing, we'll see later. Okay, so before that, what is a, if you have a residue, we have a higher order pole. What is the meaning of higher order pole? So that is I mean, like let's say you have 1 over Z minus C whole square Fz. So will that be a higher order pole? Yes. So many you need to know what is a pole. So a point z naught is a pole of a function if it is a 0, 1 by f, and 1 by f is holomorphic in a neighborhood. I mean, it's complex differentiable. So that's why it was, you see, fz, this fz, it was at C, it has pole because 1 over fz, that is z minus c, has a 0 at C, and 1 by z minus c, you know, it's very nice function. Sorry, z minus c is a nice function, all normal function, so it will be differentiable. So it's okay, that's a, it will have a pole. So now if I take fz is to be like this, then what will happen? We need to check whether z minus c whole square times fz is finite or not, all those things, right? If that happens, then what we say, that is a pole, right? I mean, pole refers to nothing but a isolated singularity mainly. See, yeah, I'm assuming that all these things you know already. So that's when we have a when we have pole. So what we do, we can find out residue corresponding to that, and residue theorem says that if you have a, you have this type of integration, you can directly evaluate if you know AKs are pole of the function fz, and then residue already we have seen how to define it, right? So that is one thing. So that is directly you can do. So this integration for arbitrary function is not easy. So what, if you know the function has some, all the, you know what are the poles function has, and then you can find out the residue because you know the function definition explicitly, and then you just directly write this 2 pi I times summation of uh, summation of residues of the poles, right? And then it comes to cos integral formula, which says that nth derivative of a function c, sorry, of a function f at c will be given by this fz over z minus c to the n plus 1, that counter integral of that function over gamma, where f is analytic over gamma. Any uh, gamma it can be, but F has to be analytic on that gamma, and C has to be inside that, right? C has to be inside that. Okay. So these are the few things I wanted to say. I mean, before beginning the thing. So, so a pole is actually a typical type of isolated singularity, maybe, right? So if you have, I mean, the point Z0 is an isolated singularity of a function f from C to C if fz is analytic in the ball of, I mean, punctured disk of radius r centered at Z0 but not analytic at Z0. So that is the isolated singularity, and isolated singularity will, a pole is a type of isolated, mainly pole is a type of isolated singularity. So a complex number, a complex function f has a pole of order m at a point z naught if m is the largest positive integer such that if a minus m, this is a coefficient of the Lorentz series, Lorentz expansion fz will have a, when it is a analytic function, at least over other than z naught point, if it is analytic in the neighborhood of z naught, then it will have Lorentz series expansion. So in that Lorentz series expansion, you have a power of a minus m. If m is the largest positive integer such that a minus m is not equal to 0, then we will say we will say it has a pole. There is a pole of order m. Okay, so we'll see those things. So I think you will understand when you do other things. Okay. So here you see fz equal to z minus c whole square, right? What z minus c to the power, let's say 50. So you will see it will be, if you expand it in the Lorentz series expansion, it will be, you will have maximum the coefficient of, I mean, you have a minus 50 maximum you can get. See, Lorentz series expansion, you have a n x to the power, sorry, not x here, z to the power n, and n belongs to z, right? That z, a minus m, maximum a minus m will be not equal to 0. A, after that a minus 51 and all this thing will be 0. That's what it means. If it is not 0, it is keep on going, then that is called essential singularity. Okay. So we'll anyway see all those things here while doing the, while solving the questions. Okay. Okay. So now use the Cauchy integral formula. Come to integrals involving rational functions. So use the Cauchy integral formula to evaluate this integral. How to do that? So when you are watching with the video, you just pause for some time, you try to do first and check whether you have done it correctly. If not, at least if you have tried, then you will see where you have made mistake when I do, right? So the first thing is you practice first. You try first. Whatever time it takes. So yeah, so that's so how to do this. So this is nothing but integration over mod z equal to 3 z square minus 3z plus 4i over z plus 2i. This is dz. So whenever you have all these things, you need to try to find out first what is the What are the singularity of the function? This is a function fz. You need to find out the singularities. If the singularities lies inside the domain, then only it will be counted. Otherwise, it is the function. If there are no such singularity inside the domain, just write this integration as 0, right? So let's say you don't have that thing, right? So you, because what are the singularities? Singularities of fz are, no, you have only one singularity, right? Singularity of fz is at z equal to minus 2i. For all other values, it won't be a singularity. It will give some value. So, what is the singularity? That at that point is not differentiable, but all other point differentiable. Or I mean, you can see in a way that 1 over fz. If you take 1 over fz, that will have 0 at that point, right? So only singularity will be z equal to 2i, right? Minus 2i, sorry, z equal to minus 2. So by Cauchy integral formula, what you get? First of all, you have to check that whether z minus z equal to minus 2i is inside z equal to 3 or not. So minus 2i. So what I would say, check whether z equal to minus 2i lies inside mod z equal to 3. So minus 2i, for that what we do, minus 2i modulus we will have to take, that is nothing but square root of 0 square plus minus 2 whole square. That is nothing but 2, right? So that is less than 3, less than equal to 3. So minus 2i lies inside, z belongs to C such that mod z less than equal to 3. So then you have a non-zero value, and what will be that? C means z equal to 3. You have fz over z. So what you can write here, so instead of this fz will have, so singularity of fz, that is one thing. So first of all, you have to find out whether it is singular at that z equal to minus 2i. This is fz. Sorry, this is fz. That is not a problem. So now what we'll do, so what you can write this as gz minus z minus 2i, right? So then by Cauchy integral formula, this equal to 2 pi I times, as now what you see, this gz will not have any problem, any other singularity. So gz, so 2 pi I times z times minus 2i, right? This is by Cauchy integral formula. By Cauchy integral formula. That implies 2 pi I times, what is gz? What is gz? Gz equal to z square minus 3z plus 4i. So minus 2i whole square plus 6i, right? minus 8i square means plus 8. So 2, right, 2i square. So this is 4i, 2i square. So not 8. So it will be just 4i, right? This is just 4i. 4i. So what it gives? 2 pi I times 4i square means minus 4 plus 10i. So that you can write as pi times minus 20 minus 8i. That's all. That will be the answer. So now let's move to the next question. And yeah, this is the answer again. It's written it nicely here. And then we move to the second question. Okay, this will be similar way. Try to do it again. Then we'll do. So how to do this one? So what are the things we have seen? What are the formula we have learned? So try to use those formula. So I have said this is Cauchy integral formula. What Cauchy integral formula says? This is sorry. 1 minute. Okay. So what does cos integral formula says? I will write it. So first of all, we'll try to do this problem in two different way. We'll try. Let's see whether we can do. So first one is cos integral formula, which is as usual. What you know is okay. So if n at c is equal to n factorial over 2 pi I, then close integration over gamma fz over z minus c whole to the power n plus 1 dz, right? There's a cos integral formula in the higher derivative, right? So what we have here is, we can see it is like, if you take fz, I mean c is if it's analytic on c, it has to be okay. So first, if you find out the singularities of fz, I mean of this function, singularities will be z equal to 0 and z equal to 1 plus I at 1 plus I. But if you just, without doing anything, you just write this at z equal to 0 and z equal to 1 plus I, it will have problem, the whole function. But if you see, 1 plus I does not belong to z, belongs to c, such that z less than equal to 1, right? As 1 plus I mod will be square root of 2, which is greater than 1, right? But z equal to 0 will lie inside that c. So we take fz to be z plus 2 over z minus 1 minus I, right? Then fz is analytic on c, which is equal to z such that modulus z is less than equal to 1, right? I am not including z square, that's right. So thus our integral becomes, so thus z square z plus 2 over z square times z minus 1 minus I becomes integration fz over z square, which you can write as z minus 0 whole square. Now you see, this is nothing but gamma fz over z minus 0 whole to the power n equal to 2. So if you know this, I mean this is, sorry, n plus 1 with n equal to 1. Why I am writing like this? Because I want to make it like this form, right? So this will be what? So this will then go here, this will go here. So n factorial over means 1 factorial over 2 pi I times 2 pi I times, so 2 pi I, it will be just opposite one, inverse. So 2 pi I times 1 factorial times, it will be f, the first derivative of f, that n. So this n is important, it has to be n plus 1 at, it will be at 0 because 0 is the point. So that is nothing but 2 pi I times, what is now f, first derivative of f. So fz is a nice differentiable function, it's a polynomial type of function. So this one f prime z, you can compute, it will be this whole square times z minus 1 minus I minus z minus 2, which will be minus 3 minus I over z minus 1 minus I whole square. So that's why f prime 0 or first derivative of f computed at 0 will be minus 3 minus I z minus 1 minus I whole square computed at z equal to 0, that will be 2 pi I times minus 3 minus I over 1 plus I whole square. Okay, so that nothing but it will give you minus 2 pi I times 3 plus I over 1 plus I square means, what is 1 plus I square means 1 plus 2I plus I square, mean 1 plus I square will be 0 and only you will remain it 2I. So that is nothing but minus pi 3 plus I. That's all. That will be your answer. See how easily we can obtain this using this formula. You just only need to remember this formula, then you are done. Then everything is okay, right? So now uh, we'll evaluate this using residue theorem, right? You can use residue theorem also. How? Okay, so we don't have any place here. I'll do it in the at the end actually. Okay. So let's say maybe here. Okay. So question is to derive this one z plus 2 over z square times z minus 1 minus I times dz by modulus of z equal to 1. This you have to evaluate, right? So what are the poles? First of all, poles has to be inside this. So first of all, singularities, then poles. Singularities are 0 and 1 plus I, but this 1 plus I does not belongs to C. Sorry, 1 plus I does not belongs to this Z such that mod Z less than equal to 1. So we only singularity possibility is 0. So whether that is poles, then we can use the residue theorem. Why? So this C, we have Cauchy integral formula which is in terms of this, but we have residue theorem which is more general. Just integration over gamma fz dz you can write like 2 pi I times residue of all these things, right? So yeah, let me find it. Yes, so singularities of, so 0 is the only pole now. So 0 will be the pole because you see limit z tends to 0, uh, so what we have seen, that is
0 is a pole. We know 0 is a pole, and then we have to find, so because limit z square, limit z tends to 0, z square times z plus 2y, z square times z minus 1 minus I, that is equal to 2 over minus 1 minus I, right? That's the definition of pole, right? I mean pole of order 2. So z 0 is pole of order 2. That implies now you can find residue of g of f with respect to 0, right? That's what we denote it here. See this. So if it is a pole of order p, then we write like this. So residue of f comma c will be 1 over p minus 1 factorial, limit z tends to c dp minus 1 over dz p minus 1 z minus c whole to the power p dz. Okay. So this order will be changed now. F comma 0 will be, is 0 is a pole of order 2, so this will be 2 minus 1 factorial d d d to the power 2 minus 1 dz 2 minus 1, right, of z minus 0 whole to the power 2 fz, sorry, not f, yeah, fz only, but this one uh, of limit z tends to 0, right? Limit z tends to, that is the definition of residue, right? So how we will evaluate this one? This one would be 1 over 1 factorial limit z tends to 0 d dz of z plus 2 over z minus 1 minus I. If you remember, then this one will be limit as z tends to 0. This one will be z minus 1 minus I whole square, and it will be same like z minus 1 minus I minus z minus 2, so minus 3 minus I, and you can easily see this is not a singularity, and also minus 3 minus I over 1 plus I whole square, that is residue. So that implies minus 3 minus I over 2I. So what does the residue theorem now says? Residue theorem says that over gamma this fz dz will be equal to summation over, sorry, to pi I summation over residue of f and ak. So in this case it will be 2 pi I times only one pole which is of order 2, and that value also we know, minus 3 minus I over 2I is equal to pi times minus 3 minus I. So check that whether we got the same result while doing using Cauchy integral formula. Pi times minus 3 minus I, remember, pi times pi times minus 3 minus I. That's all. So we got using two different methods, but they give same results, right? It's not a different result. That is the answer. Yeah. So now we come to a different question. It says that find the radius of convergence of the series. This. Okay. Try to do this. Okay. So as no one is here, I'll just do it. But while watching the video, please do not just keep on watching. So pause it and do it. That is very good for you. It will be very helpful for you. Okay. Yeah, so this is the third question for our session. For our discussion session, this is the third question. We did first question and second question in first question we did, and then second question we did in two method, and we saw the same result. And one was using cos integral formula, and second one was using the most general, which is residue theorem. Okay. Yes. So now we come to another type of question. The last two were kind of similar, but this is a little different. But what we need to know, what is the radius of convergence? So if you have a n z to the power n, then radius of convergence r will be limit as n tends to infinity a n over a n plus 1 that modulus. That's all you need to know. In our case, a n will be what? Remember, it is z over 2 to the power n is written. So a n will be n over n plus 1. Not only that, with 1 over 2n. Right? So what will be a n over a n plus 1 will be n by n plus 1 times 1 by 2n, that times 1 over a n plus 1, which will be n plus 2 by n. Am I doing correct? Or is n over n plus 1? Then it will be n plus 2, yes, times 2 to the power n plus 1, right? Right. So that gives nothing but 2 times n plus 2 times n over n plus 1 whole square. So that is nothing but if you take, it will be 1 over, you just divide by n square. It will be 1 plus 1 by n whole square. So as n tends to infinity, this will converge to 2, that you all know, right? 1 plus 2 by n will converge to 1. 1 plus 1 by whole square, it will converge to 1. So 1 over 1, and you have 2 before that, so it will be 2. Okay. So that is just, it was simple. Need to know only what is the radius of convergence formula. Okay. That's all. So done. Now let's do this one. So Taylor series expansion mainly. So this is also easy. So how to do this? What usually you do when it is in a real number scenario. So that same thing we will be doing here. So see, we need to find out a series, right? So you know already z minus 1 is in nice form. So z minus 1 over 3 minus z will be equal to z minus 1 times 1 by 3 minus z. So now you know how to deal with this, right? It's not a big deal. What maximum you can do here? So z minus 1 times 1 over 3, again you can take 1 over 1 minus z by 3, that, and then you can write z minus 1 by 3 times 1 minus z over 3 inverse, and you know how to deal with that. So you need to find out around z equal to 3, so it is it's not an big deal. Z equal to 0 neighborhood, so it will be okay. So z over 3 will be smaller, and that will be convergent series also. See, if you were in online, now I would have just, if you have asked something I can say, but it is not easy, just no one is here and I am just telling, so that is different thing. So I have to assume something that you know already, or that type of things. So, but anyway, leave those things now. So 1 minus z whole to the power inverse. So I will just read that answer here because it's very easy. So just like I said, 1 over 3 minus z as a geometric series multiplying by z minus 1. What we do? See, not do forget all these things. You just know z minus 3 or z minus 1 over 3, that is here, and you have 1 minus z by 3 whole inverse, and that is a geometric series. It is given by this, right? So 1 plus z over 3 z square over 3 square, and it is keep on going, right? Okay, so then what you do, this 1 over 3 keep it, and then you just multiply by z minus 1 and make some arrangement, so that you get z cube the as, I mean, the coefficient of z cube 1 minus 3 square by 1 minus 3 cube, and that will be z cube times 3 to the power 4 3 minus sorry, not 3, yes, 3 to the power 3, 1 minute. So what will be this? This will be 3 to the power 3 to the power 3, 3 to the power 3 times 3 minus 1. So it should be 2 over 3 to the power 3, not 2 over 3. Sorry, yeah. 2 over 3 to the power 3, and you have this 1 over 3 here also. So this type of mistake is very, I mean, it can happen. I have heard what I'm saying. So this 1 over 3 we will not multiply in the exam. So that is z cube times 2 over 3 to the power 3, and you take 1 over 3 also, you just multiply, that will give you 2 to the power 2 over 3 to the power 4. That is the coefficient of z cube. Why coefficient of z is important, you will see later, because if you want to know whether at some point you want to see whether that is a pole or essential singularity, it will be difficult for you. So if it is uh, you want to know essential singularity, whether isolated singularity is essential or pole, that will depend on that series expansion and the coefficient of z minus p or z minus m, that type of coefficient. Okay, because usual Lorentz series you will have a n z to the power n or z minus c to the power n, where n belongs to z. So you need to first, you need to find this type of a minus 10 or some such thing, you need to find out to know whether how much you have the Lorentz series expansion. Depending on that, you can say that whether the point C is singular essential singularity point or not. Okay, so that's why these are important. Okay, so find out the Lorentz expansion for this one. How to do? What is Lorentz? I mean, the Lorentz series, I said already, that type of series, you have to mainly find out this type of series. Okay, where n belongs to Z, that's all. So here what we will do is, so we have, so first of all, you need to find out in the neighborhood of the point 1, right? So when you have neighborhood of the point, you need to mainly find out Z minus 1 to the power n, where n belongs to Z. So our aim will be to find this one, right? So to do that, we take 1 over Z minus 1 whole square. See, we should not disturb this quantity because already we need Z minus 1 type of term, right? Now we have Z minus 3. So what one can do, 1 over Z minus 1 whole square, write Z minus 3 in terms of Z minus 1. That is minus 2 plus Z minus 1. Right? Again, 1 over Z minus 1 whole square. See, this term, it can also be there because your series is summation over a n belongs to Z and Z to the power n, or Z minus 1 whole, in this case Z minus 1 to the power n. So 1 over Z minus 1 whole square, that term can be there, so we don't worry about this. So this, let it be, right? So, but other term, this is, we have to expand. So you take 1 over minus 2, right? Then what will happen? 1 over 1 minus, right, Z minus 1 over 2, right? So what that will be, minus 1 over 2 times 1 over Z minus 1 whole square. This will be 1 minus Z minus 1 over 2 to the power n, sorry, to the power minus 1. That is equal to minus half 1 over Z minus 1 whole square times 1 plus Z minus 1 over 2 plus Z minus 1 whole square by what was our that, yeah, 1 minus Z square Z cube by 3 factorial, and all these things will keep on going, right? So you, if you have this a minus 1 minus a whole to the power minus 1, that will be, I mean, 2 square and keep on going, right? This is a geometric series, and this one you can write because Z minus 1 over 2 is less than 1, as is given. So that again you can write minus 1 over 2, 1 by, you just take inside this one, 2, plus 1 by 2, 1 by Z minus 1, plus 1 by 2 square only, and plus 1 by 2 cube, z minus 1, z minus 1, and keep on going. What you can see here from here, it will be so it has to be the summation over. I want to write in terms of a n z minus 1 to the power n. So it, of course, it will be maximum n minus 2, n equal to minus 2, and it will go up to infinity. And then, of course, it will be z minus 1 to the power n, right? That is correct. But then what will be the coefficient? It will be some 1 over 2 to the power, of course, negative always there, that is, keep it 1 over, see, first one it is 2, second one is 2 square, third one is 2 to the power 3, and keep on going. So first one is 2, but it is corresponding to n equal to minus 2. So this should be n plus 3. Will that work? So when it is n equal to minus 3, then it should give 1 over 4. Sorry, when it is minus 1, n equal to minus 1, if this is corresponding to n equal to minus 1, so it is giving. So that's all. So you got the Lorentz series expansion of the function. So find the Lorentz series expansion of the function fz equal to this. You got this. So this is very important. You will see why later. You will see. You will understand. Maybe not in this class, but exam question, many places you will see it will be very helpful. This Lorentz series expansion. Okay. So now we move to the next question. Maybe here also, yeah, you will understand maybe. Okay. Let's see. Lorentz series expansion, why it's important, you will understand this question also. Okay, so first option is try by option also one can try. It's z equal to 0 is removable singularity or not. So to do that, what is the easiest way? Just take limit at z tends to 0 whether it is finite, right? If it's finite, you can remove that singularity. Let me z tends to 0. Just by putting z equal to 0, it seems it is singularity. It has singularity. Of course, it has, but whether that is removable, okay? Whether you can put a value of f0 equal to something and then you can make it some singularity, you can just remove that. So for that, what we see this as a limit for first option, limit as z tends to 0 e to the power 2z minus, not here, minus 1 over z will be limit z tends to 0. So it is 0 by 0 form. So just if you take derivative 2 times e to the 2z, so it will be e to the power 2z 2 times e to the 2z equal to 2. It's a nice function. So just take, you can do L'Hopital type of things to make sense. I mean, if you don't want this, then you can say that it's just it exists also. So it does exist. This exists. So removable singularity is this option. It is correct. Whether z equal to 0 is simple pole, and then you need to find out the Lorentz series expansion. Lorentz series expansion, how we will do? So what we have given, they have given e to the power 2z minus 1 over z. right? So that is nothing but 1 over z. What is e to the power z formula? 1 plus x, right? 1 plus x, yeah, that's correct. 1 plus x square by 2, x square 2z whole square over 2 factorial plus 2z whole cube over 3 factorial plus dot dot, and minus again 1 over z, right? This e to the power z minus 1 is there, so that I am writing here. So that implies it will be 2, 1 over z, and this 1 over z will go, so it will be 2 plus 4z square, means 4z over 2 factorial plus 8z cube over 3 factorial, no, 8z square, 8z square over 3 factorial, and plus, no, this will keep on going like this, right? So you can easily write like 2 plus 2 square z over 2 factorial plus 2 cube z square over 3 factorial plus keep on going, and that is nothing but summation over n equal to, here it will be 0 to infinity, not 2, it will be 2 to the power n uh, plus 1, right? N plus 1 over n plus 1 factorial times z to the power n. Which option is this? So this should be correct one. So this is C is also correct. So whether z equal to 0 is a simple pole or not, how do you show that? So when you have this is a singular, so it has a, it is a, so it has a pole or not? It has a pole. Z equal to 0 will be a like singularity, but what we need to check, limit as z tends to 0 whether it is simple pole. So for that z times a to the power 2z minus 1 over z, it exists, right? That's all we have. No, this is a, okay. Where was the question? Where is the, where we are doing? Yeah, so what is the simple pole definition, whether it will be simple pole or not? Let me think just 2 minutes maybe. So for the simple pole, what do you do? Simple pole at Z naught, just leave it this one. At Z for Z naught at simple pole at Z naught, you try to find out whether this Fz Z minus Z naught times Fz is analytic function or not. So or the other way, so what we need to do is whether there is a principal part is alternatively its principal part is some c over z minus z naught. So do we have this type of things here in the Lorentz series expansion? No, right? So this cannot be a simple pole. Yeah, so I will say now just what is the one of the easiest way to check. Yeah, I wrote this, it was correct. So limit as z tends to 0, z times e to the power 2z minus 1 over z. So first of all, this as from this definition, z minus 0 times e to the power 2z minus 1 by z, that is nothing but regular 2z minus 1, that has to be analytic, that is one thing. And another also you need to check if that is nothing but limit as z tends to 0, limit z tends to 0 e to the power 2z minus 1, this has to be non-zero number and finite number, but it is becoming uh, 0. It should not, I mean, it should not be 0, so this should not be 0, but it is becoming 0. So this cannot have finite pole, so it is not, so 0 is not a simple pole. But 0 is a removable singularity, you have understand, and you have understand that. So it has a pole, it has a pole at z equal to 0, but it is not a simple pole. I mean, it started with z equal to 0 as a pole. I mean, it has a singularity. Singularity. Right. So z equal to 0 is a removable singularity, that is correct, and then this option C, whatever we have done, it is correct. So now we come to the seventh question. Okay, whether is which pole, whether these are pole of order 2 or 1, they you need to find out. So first of all, try to factorize this one, because from here only you will know whether something some what are the singularities. So you can see easily z equal to 1 will satisfy this. So what we do, we usually do like this. 4 times z minus 1. So z minus 1 times z minus 2z plus 4, right? Yeah, I made a mistake. You have seen this 4z. It will be plus 4. So it will be z minus 1 times z plus 2 whole square. So the singularity point can only be minus 1, sorry, plus 1 and minus 2. So when you have this z equal to 2 is a pole, so it cannot be. Z equal to I is a pole, it cannot be. Only these two are possibility. Answer is A and C. That is okay. But these possibilities now we are not sure. But the possibilities are only this 1 and minus 2. So let's now do it. So what we have that fz, then it becomes 2z square plus 13z plus 3 over z minus 1 times z plus 2 whole square, right? So to know the pole order of the pole 1, pole z equal to 1, sorry, pole at z equal to 1, okay, pole at z equal to 1, what we do, limit, will be taking limit at z tends to 1 because it is of order 1, so it won't be problematic. So no, what about the order? So here we don't do any derivative and all, okay? So z minus 1 times this, if you do fz, that will give you limit at z tends to 1, 2z square plus 13z plus 3 over z plus 2 whole square. You see here you don't have any problem, you just put that, so value 2 times 1 square plus 13 times 1 plus 3 over 1 plus 2 whole square, so that is 9, 18 over 9 is 2, which is not equal to 0. So as you started with z minus 1 times this, so that implies you have taken the, this is z minus 1 to the power 1, so order is 1, that's why. So now if you want to find out pole at z equal to minus 2, right, is of order 2, as you will see this 2, so I am claiming, so z tends to minus 2, z plus 2 whole square, this whole square is, this is 2 times fz, and what is our fz? Fz is this fz, so which will give you 2z square, z tends to minus 2, 2z square plus 13z plus 3 over z minus 1, right? That's all, because z plus 2 whole square will get cancelled. So it will be minus 3, and this will be 8 minus 26 plus 3. 11 minus 26 is minus 15. So it will be 5, which is not equal to 0. So this 2, this 2 becomes the order of the pole. So don't write this one as pole, okay? Order of the pole. So this is the order of pole. So order of the pole is 2, and so that's why these 2 will be correct. These 2 are correct. So 7th question is done. Then we'll move to the 8th question. As none of you are here, so I will finish maybe early because you don't need to discuss also, right? So but you try at home, watch the video and pause it and try and then watch. Okay. Yeah. So now whether z equals 0 is a simple pole or not. So z equals 0 will have a singularity that you can see 1 by z type of forms are there. So but whether it is simple pole. So mainly limit as z tends to 0. Okay. For simple pole, what we have discussed already, see here, simple pole. So that has to be non-zero number z times z times fz. This has to be non-zero finite number. So for this, you just try to find out the Lorentz expansion. Okay, that is better. So if you have essential singularity, you cannot have simple pole or removable singularity. So use those things, and then you can show that it will have removable. It will have essential singularity. So how do this e to the power 1 by z? So that will be 1 plus x square over 2 factorial means z square plus keep on going. So z times e to the power 1 by z will be, just multiply that. So that will be z plus 1 plus 1 by 2 factorial z and plus keep on going, right? So you have infinitely many z to the power minus n terms, so it is not stopping anywhere for any finite n. So what I am telling, a minus n is not equal to 0 for any finite n. For any n, it's finite n means, yeah, for any n, and that is around you have z minus 0 to the power n. So 0 is an essential isolated singularity. So all other options will then get cancelled. So like discarded. So when you have essential singularity, you cannot have pole. You cannot have pole first of all, and then removable singularity also. Only this one is correct. Yeah, let's do what about this. So the residue of this function you need to find. So if z equal to minus 2i, you just put the value of z equal to minus, sorry, not put the value, z minus 2i, means z plus 2i to the power 3 times this. If you will see that will be non-zero number, finite number, so it is a pole of order 3. So residue of this function with respect to minus 2i, which is a pole, will be residue of f equals to minus 2i, will be given by it is of order 3, right? So yeah, so it will be 3 minus 1, right? 3 minus 1, not only 3 minus 1, 3 minus 1 factorial d d 3 minus 1 z 3 minus 1. Of course we need to take limit also, that I will write z plus 2i to the power 3 times f z, and we'll take also limit. Yeah, write it like this times limit z tends to minus 2i. What does that give? That equal to 1 over 2 factorial is 2 times limit z tends to minus 2i d2 over dz2, and this will be e to the power z over z square. So what does that give? So that is 1 over 2 limit z tends to minus 2i. First let's take derivative of this. So what is ddz of this? ddz of this. So that will be z to the power 4, right? Z to the power 4 z square e to the power z minus 2z e to the power z. So you have to take again integration, right? Okay, so it's becoming little, let's put no problem, but we'll do it. So z square e to the power z minus 2z e to the power z times dz, so that will be 2z. Okay, that's not a problem. So I'll write it here again. So e to the power z square e to the power z minus let's write it as z square minus 2z times e to the power z over z to the power 4, this. So that will be again equal to z to the power 8, right, times z to the power 4 z to the power 4 times 2z minus 2 e to the power z minus z square minus 2z times 4z cube e to the power z. See, once you have you know this, at minus 2i we will evaluate the value, and then you just put z equal to minus 2i here, z equal to minus 2i. What will happen? So to z to the power, first of all try to z to the power 4. What will be z to the power 4? No, yeah, this one you can once more you can simply write, because z to the power 4 even you can take out. So 2z minus 2 times e to the power z and minus 4 times you can take z minus 2 e to the power z over z to the power 4. Yeah, that you can write. So now what is z to the power 4? If you put z equal to minus 2i, so what I mean is limit, so this one you can write it equal to minus 4i minus 2 e to the power minus 2i minus 4 minus 2i minus 2 e to the power minus 2i over minus 2i to the power 4. So 2 to the power 4 is 16. I to the power 4 will be 1, right? So that is nothing but e to the power minus 2i over 16 of 8i minus 4i. So it will be 4i plus 8 minus 2, it will be plus 6. Is that the answer? No, something I have messed up, right? So it will be 1 plus 4i. This is minus 2. This is 4. Okay, so you try this one in your home. So let me check once again also. So it is this and e to the power z over, if the things are correct, e to the power z over z square, and we take z to the power 4, z square times z, then e to the power z minus 2z. Okay, so yeah, 1 over 2i will be there. So this 1 over 2 we were missing, that is okay, but z to the power 8, z to the 4 times 2z. Yes, we have made the mistake here. We found out the mistake. Okay, so we will have another term here because we took derivative but we did not do this. So z to the power 4 times, it was, once it was 2z minus 2 times this, another will be z square minus 2z e to the power z. Okay, so we'll have some, we'll have to add one term, that is z square minus 2z times e to the power z also will be there. So that means, what is z square? It will be minus 2i square, minus means minus 4, and it will be plus 4i times e to the power minus 2i. So whatever we got, with that we will have to add. So first of all, half is there because that why we were missing, times minus 4 plus 4i, right? If we do that, what will happen? Half times e to the power minus 2i over 16. I am keeping this, and then it will be 2 plus 8i. That is nothing but e to the power minus 2i over 16, 1 plus 4i, and we are done. That was the that has to be the answer. These are incorrect, and you can see the answer. Yes. So what is the value of this integral? So this is very easy. I don't do it because we have done same. So you can take it as a homework because I have done the, if this is a solution is also given here, and this one also same. So this type of things are same. So 11th one you can do like the same way, because fz you can try z square minus 2z plus 2, you just factorize it, z minus a, z minus b. Try to see whether a and b are inside c or not. Very easy to see. Most probably you will get like this 1 plus minus I type of terms, and you have to check 1 plus, let's say for 1 plus I, whether this is here 1 plus I plus 2, whether it is less than or not. So for that, what will happen here, it will be 1 square plus 1 square, right, plus square root of 3 square plus 1 square. So it will be square root of 2 plus square root of 10, whether this is greater than 8 or not. So you will see this will be kind of 3 point something, this is 1 point something, it cannot be, so it is less than. So similarly 1 minus I, you want it to check whether that is belong to, so that will also, you will see both are inside this, and they are also pole of order 1. So you need to find out the residue, and you take 2 pi I times summation of residue. Also you can do uh, I mean, if you have like z square over z minus a times, this is alternative, okay. So that is z minus a times z minus b. A and b are two complex numbers, so always you can write 1 by b minus a times 1 by z minus b minus 1 by z minus a times z square, or 1 by b minus a times z square over z minus b minus z square over z minus a. Now you can use Cauchy integral formula. Done for today. Try to do all this. I try to do, I'll practice all the problem. Yeah, and at the end I would like to say thank you. Have a nice day.